Let's take a look at the different types of veneer we have, how they're cut, and then how we can use that understanding to recreate digitally our veneer. So I have here representation of the most common veneers. For example, a rotary cut. And you see the red lines, that's basically the slicing direction. So we take the tree, put it onto a lathe, spin it, and then we kind of like peel off the veneers. And you see this will turn into a pretty nice topology. If you want to have rather the cathedrals in the veneer, then we have to go with kind of like a plain slice. So we cut kind of like this part out of a tree, and then we horizontally slice along it. The next one, if we actually do not want to have the cathedrals, we just want to have nice parallel lines, then we can use a quarter sawn cut. So you see we quarter the log, and then horizontally we just slice through it. And a variation of this one, because we can see these flakes here, which are part of the medullary race, we kind of like take a quarter but just rotate it, or we slice at a curve, and you can see these elements here. So we can still get the same line pattern, but we don't really see those flakes anymore. Different representation I have here. There you can see that again with the knife and the cutting direction. And that basically explains the different types of veneers we have. So let's take a look at the medullary race. See here I have a scan, the end grain on the one side and the other side. You can clearly see that based on the side of wood which I scan, you can get different patterns. The left one, there you get more actually the cathedrals, so the wood grain, and here we deal more with the wood lines. But for example, this is more kind of like a quarter cut. There we have the medullaries. So if you take a look at where my mouse is, there you can see that there are actually lines that connect the individual grow rings. And that's basically when we cut through it at a certain angle, what creates those blobs basically. Some find it interesting, they can glow nicely. Also when you put varnish etc. over it, they however can also be very distractive because they kind of are annoying because you don't really see the wood grain as clearly. Also what is very nice to see in the scan up close, the different types of wood. Basically you see the porcelain solid, the porcelain solid, and the area here with the pores, that is for example in this image what you see here, which is a little bit more redder, or for example here these small lines. And then what is more solid, that's actually the wider area. If I zoom in a little bit more, there you can even see maybe sometimes the saw cut through some of these pores. So let's take a look at our software. So here now we have a very basic tree trunk. The bark is removed and we're ready to cut our veneers. Again, before we start, the way how a 3D material like wood works is you have a center, and in this case here now I use an empty. So you see the texture coordinate actually uses the empty as the center. So from this center the rings grow. So here when I move this one up, now you can see actually how I'm controlling the position of the rings in kind of like this three-dimensional material volume by the empty. Okay, so let's take a look at the plane slice. Now you see this again. So that's kind of like the way how it would look. And if we now take a look at, for example, the top area and the bottom area, you can see I will actually get different types of veneers. The closer I get to the core, the more cathedrals, for example, I could get. And this is basically here the knife, and the knife will come in and just step by step start slicing through it. So I will end up with sheets of veneer like this. See? Pretty simple. Okay. That's also economically the most easiest one to do, and thus it's pretty cheap. Then here's our quarter. So you see the way how it's mounted, and then we take our knife and then ching ching ching, just cut step by step through it. And you see basically when the knife is here, we cut really nicely perpendicular through the rings, but I do not really do this one here because you can see where the knife is and how the rings are. They're not really, well, perpendicular to each other. So keep that in mind. That's important for the next veneer. And there you see now, for example, the result of the quarter saw cut. So nice lines. And that's simply, as you can see, the material is the same, but how I slice through it is just different. And then also, well, we have the rift cut, and only certain wood types actually have the medullary rays. So I can, for example, rotate the log and then just slice at it, rotate the knife or rotate the log. So I try to always cut, for example, at different angles, so that I get more or less always a position where the knife and the rings maybe become or turn into perpendicular arrangement to each other. Or I could rotate it, or I mean rotate the way the knife doesn't go linear, but everything works more in a circular path. So I can get, for example, veneers like this, and then obviously later we put them flat. But this basically would then be the way to cut when you want to minimize the appearance of those medullary rays. Okay, so the question is now, well, how can we, for example, create now our veneers so that, for example, for a furniture project, we can correctly create the sheets of veneer we need, and then we can do our veneer layout. If you go to Google, type in wood veneer matching, you will find a lot of useful images. So the question when we have our slices of veneer is, how do we apply this now onto a surface? Do we want the patterns to nicely match? Do we want to create certain flows or structures? Do we want to hide the cuts or the edges of the individual veneer sheets, or do we want to show them? So for example, here in this very old graphic, but it's still pretty valid, we have a random match. So we have our individual sheets of veneer, and we try to see by moving the sheets up and down if we can find areas, like where my mouse is right now, where veneers perfectly flow into each other. But then also, where my mouse is right now, sometimes it will not. But this actually works well because the veneers have a lot of structure to it. So they're quite crazy. So you can actually hide the different edges. Slip match on the right is basically showing the edges, and we simply take one veneer, the next slice we put right next to it, the next slice we put next to it, the next slice we put next to it. A variation is then basically the book match, where you can see with the book match we actually kind of create symmetrical patterns always along the edge where veneers touch each other. And let's quickly go to here. Now we can also have diamond match, or it's basically really up to you to decide how you want to arrange them. Applied, for example, to furniture. No, this is not a good one. Here, there you can see, for example, the book match. Or, for example, here. And another one that actually looks quite good is there. So you start playing actually kind of like with the flow of the cathedrals, and you create additional patterns, and then it's up to you to decide, for example, up and down or left and right, how they can be lined up. Okay. So the question is now, how can we create the slice or position of our veneer inside the desired position of our 3D wood material, and how can we create also an image based on that? The process is actually pretty simple. I will introduce you now to texture baking. Texture baking is something that kind of comes from animation and game design, but in our case perfectly is usable for rendering actually sheets of veneer into an image. So in Photoshop then we can create our matching. So here again is our tree trunk, and I mentioned before I am using an empty. Where's the empty? Empty, empty, empty. There is the empty. Okay, so that again, that is the center of my wood material. Let's start with a very basic veneer. So here our plain slice. So let's say I would like to have a plain slice of the veneer somewhere here. So all I need to do is create a plane. For example, I position the plane to somewhere there. In edit mode here I will scale this down a little bit, maybe make this a little bit wider there, and I'm just use my my wood log here as a reference. Okay, and we'll put this onto a different layer so it's gone there, and I will show my first layer with the empty. So again, from here the rings will grow circular to the outside, and then keep in mind along the X we also are stretching the rings so we can create kind of like the cathedrals. Okay, so this now needs to use, for example, the wood material. There you see it. So because my center of the material is not defined by the object center of the sheet, so here the square, but the empty, if I take this one now and I move this one up and down, you can see I can actually go through the different layers actually of my wood log. I could, for example, also move it to the right or the left. If I actually move this kind of like to there, and this is kind of like a quarter saw, or getting close to a rift cut. Okay. So if I bring this one down, the same. If I rotate this one, you see it from the other side. And again, the clue or the trick is, this is just an object that has the wood material applied to, but because a three-dimensional material needs kind of like a volume, and with the wood one, we create rings we stretch to simulate the wood pattern. We, in addition, can work with an empty as this origin where the wood originates from. And then this one we can move around in 3D space and then figure out where is my, like, the veneer I would like to have. I could even, for example, move this one left and right, or closer to the center to get different looks. Okay, good. Let's say I want to bring this one maybe onto the same height as the empty. So let's say the empty here is there. Copy you. There, hold on. I want to recenter this one. This is 0. This is 0. Okay, good. So now our sheet is centered, and I will move the sheet a little bit further away to there. Good. Okay, so let's say this is now a position inside my tree trunk where what I see there right now onto or on the square, I would like to render out into a texture which I can write then into an image. So what we have to do is first create an image texture that fits proportionally our geometry. So for example, this one is 2 meters, well, 3 meters by, let's say, 50 centimeters. So we can use that information and say, for example, Veneer new, for example, width, so 2.8 meters, let's say 2800. I will remove 10 so it renders quicker. And the height, 500 centimeters, we will turn for the moment into 50 pixels. Okay, perfect. Then we can go into edit mode, UV unwrap. Now sometimes we get this, then we can say snap to pixels, full screen, and say cling, cling. Make sure actually, whoa, it really snaps to the corner, 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 perfect. Good. So that's fine. Now we have unwrapped the mesh and we created an empty texture. Into this texture we will write the result of this procedural material. So to do that, here we have to create another image slot, and for example Veneer new there. So this is this one. Great. To do a bake, first make really sure Alt-H and there is no hidden object. Otherwise shadows etc. might show up. Okay, then we can go to the render, go to bake, and then here we have certain settings. For example, diffuse, blah 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 blah. What we want is actually just the diffuse color. And even here we can turn the lighting off, so we just get the brute color. Now you might ask, well, I could take a screenshot of this, for example, like this. Okay, true, but two problems. First, do I really know that is neutral color-wise? Maybe I made this lighting a little bit too bright. Also, another thing is what is pretty cool about this approach, which I'm going to show you, is if we, for example, here add some more points and then I move this point, you see I am actually distorting the veneer. So via geometry, I kind of like customize my pattern a little bit. Now this is still a rectangular area, so I technically speaking, could make a screenshot. But in case, let's say this is slightly arced, then I can't really make a planar screenshot of a bent surface and get a nice unfolded texture. The second or third problem is also, well, I can only zoom in to a certain degree to make a screenshot. I would have to zoom in more and then screenshot, screenshot, screenshot. So that's a lot of work, and post-processing afterwards, that doesn't really make any sense. So baking in that case actually is quicker and more effective, and it's accurate. Okay, good. So for the baking, sorry for the excurse. Now we have all this set. Margin maybe we can set to 0, I think. This is all good, and we should be ready now to simply click bake with this object selected. And then there's a process bar, and there is now our veneer. There, perfect, no? Pretty cool. So this one we could save. Let's say save as. Oh, my hard disk is spinning up for Windows 10. And let's say this is Veneer 1. Okay. And now I can, for example, let's say, because we're making veneers, move this one a little bit. And then just do another bake. And let's save this one. And now we say this is Veneer 2. Let's move this a little bit again. Make another bake. And let's save this one. This is now Veneer 3. Okay, so if we take a look at those now, there you can see that actually we can create the different flows through the wood material. And now obviously you can understand, if we now book match, for example, these veneers, then you don't get, if in case we would only use one image and we just replicate it, when we have 6 or 10 replications, you will see it's all the same. That's not realistic, because the grains will change slightly. So by making different baked textures, we can also really simulate not only the position of the veneer, but also in real life how we only have one veneer pattern once, because we slice the wood. Okay, perfect. So that worked actually pretty good. And in a nutshell, and that's pretty much everything about how to create, for example, different types of veneers based on your position inside the tree trunk. And the last thing I would like to maybe show is here, these points I will all sharpen, crease. Then I will add a sub D modifier, maybe 2, that's fine, because when I move this one now and maybe this one, I get nice transitions between those hills. We don't want to move this one up, that makes no sense. Maybe like this. Okay, so that's by the way one way, but I could also say, well, what about if this whole area I move up and bring to there and bring to there. Now you see kind of like the way how I slice actually through something, and that I could, for example, cut as well. Could also maybe for this exercise I can straighten them all out there and there. Let's see, when we bring this one to there, so we kind of like have an S flow No? There you see. So based on how you position your points, you can create pretty nice different cuts and flows and changes inside your veneer. So if we go back and say bake, and there we have it. Okay. So here I have a screenshot of a bench from Leland, and there you see they use like the rift cut. But the problem is, as you can see, how the veneer actually flows. We don't really see the cathedrals, but there it bends nicely down and it's book match. So how could I create this one? Actually, we can do it this way. So this empty, for example, I can move down, so I get more something that looks like the rift cut I'm looking for. So more the lines. Perfect. So before I actually showed you how we can take a point and just move it left and right. But what we will do now to add some extra deformation is simply we can take this and move it down a little bit like that, because you see this mesh will be unwrapped into a straight image. Okay, so it will be deformed. So let's bake it, and if we go and zoom in, there you see how this is now arced. So let's say we will do it like this. So everything here is a tick arced. Let's just say for the sake of science. Doing texturing where Norman has gone before. And there. Perfect. Okay. So this, these lines kind of like will be stretched. So if I want this one to go down, then actually, to be honest, what I should have done is these actually should go up. There. Okay. Because later my image, that will go, I think, downwards. Okay. So let's do another bake. And there. Maybe I should have moved those a little bit more. There, tick more, and a tick more. Okay. Okay, so now you see this level of image resolution isn't really good enough. So let's go with something that's higher. This will take probably a little bit more to calculate. So, oh, did I create a new image? I don't know. Veneer new. What's this one? Ah, yeah, okay. So let's say this is large. There it is. Okay. And bake. Now, this goes pretty fast, not a big deal. Let's see while this works if there's something else I could talk to you about. Yeah, so while this is baking, I can talk a little bit about also the different types of veneers. Now, so for example, these are natural veneers. You could clearly see that based on the photo. We have the rings and the structures, the pores, a variation in colors, and this is, for example, a rotary cut, and those are plain slice cuts where we have the nice cathedrals. So these are more natural cuts. But because wood is quite expensive, I mean it grows slowly, and if you want to have certain types of woods, we can try to see, well, what are characteristics? Well, obviously the pattern, maybe density, so the density of rings, and color and pores. So wood rings, pores, colors, and maybe some details. And then how are they composed together? And that is the reason why we also have artificially generated veneer. So this is not plastic. So it's actually a different tree which grows pretty fast, but then we can cut it, glue it, dye it, re-glue it, slice it to create these individual patterns. And this is basically all just the same material, but you see, based on how they combine these steps with pores and colors and dyeing, you can create actually the illusion of different materials. And obviously this is very good also if you want to do something that looks like a rift cut. So no quarter cut where we have the rays blobs popping up. We don't want them. We just want nice, beautiful, kind of like here, like the lines. So now we have two different types of veneers: natural and then the faux one. The thing with the faux is also they're easy to reproduce, fast and cheaper, and probably better for the environment. Okay, let's take a look at our finished piece here. There we are. And you see, with a little bit of more resolution, then the stuff looks a lot better. Perfect. So if I save this, let's say veneer large, okay, that's good. And let's open this one in my most favorite image editor, because I hate Photoshop. I don't hate it, it's just too expensive for what it does. Okay, canvas, let's say there, height 3000. Okay, there, copy and paste, move this one down, and let's mirror it. There we have it. See, number one, these two, merge, copy and paste, move it down. There we have the other matching. And you see, very easy. So now you see, out of one slice I can create a much bigger texture, do then my veneer match based on the type I want, and then I have actually a high resolution texture to texture my furniture, and it will look better. Because the problem is, very often we get small scans online of wood types, but you don't really want to texture a complete of furniture with a wood texture that maybe occupies a 5" by 5" area.